You step into the coding arena ready for the challenge. The developer leads forward and gives you a task.
Given an array of integer nums and then the integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order.
The task sounds very familiar and very simple, right? But only those who have skills and efficiency can solve it quickly. I am Evasuta Alexey, and today we embark on a quest to conquer the two-sum problem from LeetCode. Today we are tackling one of the most fundamental yet crucial coding challenges, two-sum problem. But before we dive in, let's go over the problem statement. A close look at the quest description reveals several important conditions. Firstly, each input has exactly one solution. This means that the nums array will always contain exactly two numbers that form the correct answer. Secondly, you cannot use the same element twice in the answer. And finally, the order of the indices in the answer doesn't matter. Let's take a look at a few examples. First example. The nums array contains four numbers, 2, 7, 11, and 15. The target is 9. In this case, the numbers 2 and 7 add up to 9, so the correct answer is the indices of these numbers, 0 and 1. In the second example, we have three numbers in array, 3, 2, and 4. In this case, the numbers 2 and 4 add up to 6. That's why the correct answer is 1 and 2. In the last example, we have only two similar numbers which add up to 6. Even though the numbers are the same, they are two different elements in the array with different indices. That's why the correct answer is 0 and 1. Alright, it's time to figure out how to solve this problem. And first of all, let's go over the brute force approach. Of course, the most straightforward approach is to simply check the sum of possible pairs in the array. We start a loop with I running from 0 to the length of nums. Inside it, we run another loop with j from I plus 1 to the length of nums. Notice that the second loop starts from I plus 1 instead of 0. Now we simply compare the two numbers, nums of I and nums of j. If there are some equals target, we found our answer. We just need to return indices of these numbers, it is I and j. And at the end of the function, we just return an empty array if we didn't find a solution. Now let's think about time and space complexity. Does this approach actually perform well? The brute force approach checks all possible pairs in the array using two nested loops. The outer loop goes through each number and the inner loop checks every number that comes after it. This means for an array of size n, we perform roughly n-squared comparisons in the worst case. As a result, the time complexity is O of n squared, which is slow for large input. On the other hand, the solution doesn't use any extra data structures. We only store the final indices of the two numbers, which takes constant space. So, while brute force solution is simple, it's far from efficient. Let's improve our approach and make it much faster. Instead of checking every possible pair in the array, we will use a hash map to store numbers as we go. This will allow us to find a correct answer in just one pass through the array. We have an array of numbers 2, 11, 15, and 7. The target is 9. We also create a hash map where the keys are the numbers from the array and the values are their corresponding indices. Now let's iterate through the array and check each number. First, we take the number 2 and calculate its complement. The complement is the second number that, when added to 2, equals 9. So the complement is 7. Now we check if 7 exists in the hash map. It doesn't, so we store its index in the hash map using 2 itself as the key. Moving to the next number, 11. We repeat the same process. The complement is -2, and -2 is not in the hash map, so we store 11 and its index in the hash map. The next number is 15. The complement for it is -6. Since -6 is not in the hash map, we store 15 and its index in the hash map. And finally, we reach 7. We calculate its complement, which is 2. Now we check if 2 exists in the hash map, and yes, it does. We also can get the index of 2 from the hash map, and it equals 0. Since we have found two numbers 2 and 7 that add up to 9, we can return their indices. And the final result is the array of two indices, 0 and 3. And now let's write the code for our toSum function. First, we create a map where both the keys and values are integers. The keys represents the numbers in the array and the values store their respective indices. Next, we iterate through the array using a loop, allowing us to process each element one by one. On each iteration, we first calculate the complement, which is the difference between target and the current number num. Then we check if the complement already exists in the hash map. If it does, that means we found an answer. In that case, we return an array containing the two indices, first index and second index. If the complement is not found in the hash map, we store the current number's index using the number itself as the key. Finally, if we complete the loop without finding a valid pair, we return an empty array from the function. And what about time and space complexity of this solution? The hash map approach checks all numbers in the array in the worst case. As a result, the time complexity is O of n, which is much faster than the brute force approach. On the other hand, the solution uses extra space for a hash map to store the indices of the numbers. In the worst case, the hash map will have n entries. That's why the space complexity is O of n2 here. So, today we solved the toSum problem from LeetCode, starting from the simple brute force solution and then optimizing it using a hash map. If this breakdown helped you to get a better grasp of the problem, don't forget to like the video, subscribe to the channel, and hit the bell so you never miss the new video. Thanks for watching and see you in the next code quest.